Hello everyone, welcome back to my channel. In this video today, I'm going to solve problem 1472 divide browser history, and this one is a medium problem. So basically in Leetcode we have pretty many kinds of problem, and one of the most famous, one of the most popular one is the designing problem. So this one is a pretty funny one. It is like solving an OOP problem, so it's pretty applicable in real life, and also this one can be solved by many methods, many way to approach. So in this video today, I'm just going to give you guys one approach to solve this one, and I think that one is the easiest one. So let's understand the question. Firstly, you're gonna give a class. This question asks you to implement the experience when you browse on a website over the browser. So you're gonna start at the home page. You start at the home page, and you can visit another URL, or you can get back to the previous page. So that is the browser, the history, using the history one. And what they ask you to do is that you're gonna have to implement a browser history class in specific. So firstly, you're gonna have a constructor for this class that help you to initialize the object, and also help you to identify the first position. That is also the home page here, home page of the browser. And then you can visit the new page here, or you can go back to the previous page, or you can moving forward. There are many ways to do. Moving forward is like the history, but the difference between so the visit and the forward has one difference, is that they have a difference is that the history can add new URL to the home page, to the history, but the forward is just moving in the history. Okay. And you don't have to have a look at this one. You can have a look, but at the moment you have a look at the example, you understand more clearly. So explanation in here. So firstly, you're having a constructor that initialize the class browser history and assign it to Leetcode. So for easier, so firstly you're gonna say at Leetcode, right? And next you have to visit Google. Okay, you visit the Google, you see here. And next you visit Facebook. Okay, let's go to Facebook. And now you visit and then you visit YouTube. Okay, let's put YouTube here. All right, so what you're gonna do is go back one time. So because you're staying at YouTube, you have to go back to Facebook. So now you're not pointing at YouTube anymore. You're gonna stay at Facebook, but you still have to keep the YouTube here. You're not going to delete it, so you can go forward later. And the next we're gonna do is that go back one another time. So after finish this step, you have to finish this step 2 is go back to one more time. So when you go back another time, you have to oopsie, what happened? Okay, let me fix this one a little bit. Alright, so when you move this one, which means that when you go back, which means you move the pointer to the Google. And now you have finished the second step here, the second backing step, and now they ask you to move forward. Obviously, because you didn't delete the history of the Facebook, you can go back to that again. So it's here. Yep. And then from here you can visit Lincoln. So because instead of going forward to YouTube again, they ask you to go to Lincoln. Okay, very easy to understand, right? So when you visit Lincoln, you have to my bad. Okay, so when you visit Lincoln, you will have to move the pointer to Lincoln as well. And then you can go forward 2 times. So because Lincoln is the final destination, you cannot move forward anytime. You can have a look here. You can move forward anytime because there's no other URL after Lincoln. And then they ask you to back 2 times. So when you back 2 times, you would got back to Facebook, from Lincoln to Facebook, and from Facebook to Google. So now you're here. You're now at Google. And then they ask you to go back 7 times. So since you can only go back 1 time, you can just return this one. It is Leetcode, and yep, and you can see here too, because you can only move back 1 time, so that you're gonna return Google. Return Leetcode. All right. So that's how the problem is stated. It's very easy to understand, right? So the key thing is that we're gonna have a data structure, something like an array, for us to iterate, right? So we have to have something to traverse to iterate. It can be an array, or perhaps it can be using a stack, so that you can move forward. But the thing here is that if you're using those 2 data structure, it can be a little bit tricky when you guys handle some edge cases. For example, if you guys have to go back and then move forward and then visit something, yeah, so it can be a little bit tricky. So my recommendation for you guys is to use a doubly linked list to implement this problem. So what I mean by that is that I'm going to show you guys here what is the doubly linked list. So normally you guys will have a linked list. So a linked list is not really an index-based data structure. So what they do is that they just use based on these pointer to move to a row. So normally you have a linked list, a singly linked list that just allow you to move forward. But in the doubly linked list, you can also have another pointer pointing to the back, so that you guys can traverse backward. Very straightforward, right? So normally a linked list, a node in a linked list would have a type. Would have a type like this one. So struct node, and then you're gonna have the value, and you also have a node pointer pointing to the next node, right? So whenever you want to go to the next node, you have like a TMP that is equal to the node that you're pointing at, right? So what you can do is that you can go from if you want to go to the next node, it's just TMP would equal to TMP.next. That's how you guys can iterate in the singly linked list. And in a doubly linked list, it's even more straightforward. If you want to go back, you just have an add a node back like this. And then if you want to go back, you just have to TMP equal to TMP go back. So that is straightforward. So I'm explaining this one a little bit quick, because I'm assuming you guys have already know what is a linked list, because linked list is a very important data structure. You should know that before you solving Leetcode, okay? Yep, and that is the approach. So how we can use this problem is very straightforward. Let's say we have let's go back to the example up here. Okay, so you guys can see that I have already drawn here without using the index base. I'm using the pointer, the arrow. So you just have to add this one, so that this node can have the ability to go back and forth. Very straightforward, guys. So now I'm gonna show you guys the code for this one. Believe me, it's very easy. It's just ask you guys to use the data structure correctly, so that you guys can avoid to be over complicated, over engineer. So now I'm going to show you guys the code. Before we actually use the doubly linked list data structure, we would have to create it first. So here's the code for that. So I'm going to create a struct node to create a doubly linked list. You can use a class, but in this case I'm just using a struct because this class doesn't have any method, so use a struct would be better. So basically a doubly linked list would have a node pointer point to the previous one, so that you can iterate backward and the node next to move forward. And also never forget the value of it. It's gonna be a string because we're gonna store the URL here. And then we have a constructor here. In this constructor, we're gonna initialize the value for the value and also assign those two to null pointer. Very straightforward. So that is our data structure. That's the symbol, right? Okay, so in this class, we're gonna use it as our main data structure and not current here, right? So when we construct, create the object browser history, we're gonna also create the current here. So just want to know this a little bit. In real life scenario, this one is not a very good practice, to be honest. We have to do something relating to dependency injection, but it is what it is. It is just a Leetcode problem. They ask you to solve a problem, not to give you guys not, you guys don't have to give them the best code. If it works, it works. It just how you guys solve the problem. Okay, so you guys are gonna create a new node here, right, and assign it to home page. So we have the head with the home page. All right, so now what is the visit? So visit is when we add another URL to the to our data structure. So what we do is that we create another node, and then we get a current one, which is the current pointer for our data structure, just pointing directly to the new node, right? And also the new node has to point their previous to the current one, and then we have to move the current forward. Very straightforward, guys. There's only 4 lines of code, and you guys have to understand this one so that you guys can work with more complicated questions later. The next thing is that is the back method. So they give you a number of steps. Okay, so what we're gonna do is that we just iterate that number of steps, but the condition here is very important. That is, we have to check if the current previous is not a null pointer, and we have exceeded the number of steps. So we go back current equal to current previous to go backward, and we minus the steps, and finally we just return the current pointing to the value, right? And also for the forward here, it's just pretty similar to the backward. We have a condition to check if the next pointer is not not a null pointer, and the steps, if it does not exceed the number of steps. And then last thing, we have to return a current dot value. So just to let you guys know that is that perhaps in this case, in the visit method, before we assign the current pointing to the next of a new node, we have to delete the node that is currently being pointed. For example, if you guys have a look at this one, so you guys gonna see that the Facebook and the YouTube point the next to the YouTube, but then later it point to the Lincoln. So you guys gonna see that this YouTube is never got used again, so it got deleted. So in order to keep the memory safe, you guys have to delete this one as well. So that's all. So you guys gonna see that the time complexity for this one is also very simple. The visit could be O1, right? So we just create a new node and then point to that one. The step is just OK with k equal to step, and also and also this one as well, OK with k equal to steps. So this one is, despite the fact that this is a medium problem, but how we can approach it is very simple. You guys have to, because you can approach by using many ways, but using the doubly linked list is the simplest way possible. Okay, so thanks you guys for watching my video. See you guys in the next video.